Very good morning. Welcome back to independent sample t-test. And now we are with exercises. So this is exercise 6. And exercise 6 is devoted to independent sample t-test. Question 1 of this exercise we'll be doing today. Question 2 and question 3 will be part of your assignment. And I'll be, you can say, recording video for question 2 and question 3 a bit later. And maybe within 3 or 4 days, you'll get the recorded videos, which you can compare with your own answers. And hopefully by the time you'll be submitting your assignments too. So moving to this question on independent sample t-test, question 1. So let's read the question. Recent advances in surgical technology have led to an increase in the use of minimally invasive surgery, MIS, which involves making one or more small incisions using small instruments to perform surgery as opposed to making considerably large incisions using larger instruments that traditional surgery requires. One of the claims advocates of MIS makes it clear that patient experiences less pain following the surgery. To investigate this claim, a researcher followed 30 people who were scheduled to undergo cardiovascular surgery, with 15 receiving MIS and 15 receiving traditional surgery. The reported pain level of each surgical patient was recorded 24 hours following surgery and is presented in figure 1. The pain scale ranged from 1 to 10, with higher scores indicating a greater degree of pain. So the pain is given for both patients who are having minimal surgery performed and traditional surgery performed. So we have got the pain level, and it's also, you can say, the surgery which is being mentioned simultaneously. So that's there. And if you look at, you can say the questions we have to do. First of all, we have to enter this data in the SPSS file, in the data view, and then maybe you can say write the name of the variables in the variable view with label, and you can say the measure. State the null and altered hypothesis. That's A part. B part, we have to do the research question, write the research question. C part, we have to look at the assumption of equivariances. That is something called Levin's test we have to talk about. D part is we have to look at that is there, you can say, the difference in the reported pain level between the groups. Okay, so that we have to see that whether we are accepting the null hypothesis or altered hypothesis. D part is that. E part is talking about, you can say, effect size. We have to say that whether the effect size is um, small, medium, or large. And lastly, the F part, we have to write the result. So that's the question in all with us. So we repeat the question again, just for our understanding. This is the question on surgery. Two types of surgeries are being performed. One is MIS, minimal invasive surgery, and the second is traditional, you can say, surgery. Now for minimal invasive surgery, we have got, you can say, the patients, 15 patients we have got who have been, you can say, given this surgery, and their pain level is recorded 4 hours after the surgery. Similarly, for traditional, you can say, patients, we have got another 15, you can say, patients for that, and their pain level is recorded. And then maybe you can say we have to look at the questions now that come up. First of all, coming to the null and alternate hypothesis. The null hypothesis and alternate hypothesis, if you come to part A, here, if I have to frame the hypothesis, I would say this way: null hypothesis, there is no significant difference in the pain level of patients who have undergone minimal invasive surgery or have gone through traditional surgery after 24 hours of performance of cardiovascular surgery. Alternate hypothesis, there is significant difference in the pain level of patients who have undergone minimal invasive surgery or have undergone traditional surgery and their pain level after 24 hours of performance of surgery, that is cardiovascular surgery. So these are the alternate null and alternate hypothesis. Coming to the research question for the data, is there a difference in the pain level of patients undergoing cardiovascular surgery using minimal invasive surgery or using traditional surgery after 24 hours of performance of surgery? So that is the research question. Now C, D, E, and F, all these questions can be performed only when we have conducted the test. So let's, you can say, copy the data and use this data for, you can say, our analysis. So first of all, what I'll do is I'm moving to the new screen now. I'm moving to, you can say, the untitled data set. So I'm moving to the screen. I've got the data view, pasting, you can say, the variable here. And since I know it is, you can say MIS, I'm giving MIS as 1. So that is how what I'm doing for 1. So this is it. 2 will be, you can say, traditional surgery. We have got 15 respondents of traditional surgery. So I'm putting, you can say, their values here. Just getting the values of traditional, you can say, surgery people from my exercise file. So here I'm copying it and moving it to the SPSS file for you to watch. So that's there. This is how we have got the data. So we have got 15, you can say, patients who went through minimal invasive surgery and 15 patients who went through traditional surgery. Coming to variable view, variable 1 or variable 5 in this case, I'm naming it as surgery. So which surgery has been performed? So type of surgery performed is the name of the variable. Values we are coming up. One is the minimal invasive surgery, and number 2 is your traditional surgery. So this is what we have got. So I have added it here, and what I'll do is I'll simply say OK to it, and then the measure we know it's a nominal scale. Now coming to second variable where we are talking about, you can see the pain level. So I'm just running pain over here, and the label is, you can say, pain level after 24 hours of surgery. So that's the pain level. Values are not mentioned because we know this pain level is, you can see, the scale of you can say 1 to 10, where 10 means very high level of pain as compared to maybe 3, 4, or 2 level of pain. And this measure is actually scale. So that's done. So if you look at the data, we have got the data now. Surgery we have got the pain level. So the data is before us. Now what I'll do is I'll just move to the analyze part, and we'll be conducting independent sample t-test. Compare means moving to independent sample t-test, click on that, and here we have got the things. Now surgery, you can say, performed, the type of surgery performed will be grouping variable which is independent, and we'll be just mentioning 1 and 2 for this. And pain level is 24 hours. That's the dependent variable will be placed, you can see, the test variable box, and there we are. I'll just click on OK, and I have the answers before me. So now we are moving for question 3C. You can say question 1, C part, D part, E part, and F part, and all these questions will be answered from this only. Now coming to question, before we talk on the questions, you can say, which we have to answer, just look at things here. Minimal invasive surgery, we had 15 people whose data is with us. The pain level was 4.7333. Standard deviation was 1.67 something. Traditional surgery, again 15 people went through this particular, you can say, surgery. They had a mean pain level of, you can say, 6.87 and standard deviation of 1.60. I'm just rounding off the figures. And if you look at the Levin's value, which we have to do just to understand that whether we are going for row 1 of data or row 2 of data. So this significance level comes to, you can say, it comes to be, you can say, very high to 0.05. Had it been 0.05 or less than this, the significance value, we would have gone for row 2. But here the value is 0.0, more than 0.05, we are going for row 1 only. So we'll be using row 1. Now let's come to, you can say, the questions which we have to answer. The first question was, C part is whether we have to tell that, okay, fine, is there a, you can say, a difference in the variance level? Well, fine, if you look at the variance level difference, there is no difference in the population variance of the two samples. We have one sample is of MIS, this second sample is of TS, traditional surgery. So there is no difference in the population, you can say, variance of the two, you can say, samples given to us. And Levin's test of equality, you can say, at F value of 0.005 and P value of 0.943 tells that there is no difference. Had this value of, you can say, P here, the significance value or P value of, you can say, Levin's test would have been, you can say, 0.05 or less than 0.05, we would have said that variances are not equal, but here the variances are equal. Done. So C answer we have done. Coming to D part now, where we are talking on the what are we actually, you can say, the answer for the question. That is whether we are accepting the null hypothesis or the alternate hypothesis. In this case here, we are accepting um, the alternate hypothesis, and we are accepting the alternate hypothesis at p-value of 3.578 with a significance of 0.001. It is highly significant. It is 99.9% you can say confidence interval level which we are getting here. So it's a highly significant, you can say, difference, and the pain level definitely for, you can say, MIS is quite low as compared to TS. So MIS, minimal invasive surgery, people who are going through that surgery are finding the treatment to be good, pain level quite less as compared to people who are, you can say, going through the traditional method of surgery. So that's there. One point I have to just explain to you here, that this T value happens to be minus, but don't write this value of T as minus, because you can say why it is minus, because here minimal invasive surgery, which was taken as it was given value of 1, is lower as compared to traditional surgery where the value is 6.8. So since you can say the numerator is low as compared to denominator, the value of T comes to negative. Otherwise, there is no meaning attached to this negative, because had we kept minimal invasive surgery at the bottom, that is value 2 would have been given to it, and traditional surgery we would have given value 1 in that nominal, you can say, variable of surgery. It would have made no difference, and this T value would have been positive. So we have to be very clear on this, that okay, fine, it doesn't have a meaning. So that's there. So we now know that we are accepting the alternate hypothesis, that pain level of, you can say, patients going through, you can say, MIS or you can say TS have significant difference, that we know. Now talking the third, the E part, where we talk about where we need to talk about the effect sizes. Now talking about the effect size. Effect size is something very important, and we should know how strong this effect size is. Effect size, if you look at the notes, you know you can say formula there. Effect size D, small d, is equal to T and multiplied by under root of N1 plus N2 upon N1 into N2. Now N1 we know is 15, N2 we know is 15. So 15 plus 15, 30, divided by 15 into 15, that is 225. So 30 divided by 225, that comes to, you can say, point, I was just calculating it, you can say, a while back. So the answer comes to, you can say, 0.06667. And when we do the under root of that, it comes to, you can say, 0.258199. Now, the T value is, you can say, known to us. The T value is 3.578. So 3.578 into, you can say, 0.258199. The answer comes to nearly, you can say, 0.92 something. So I'm just making it 0.93. I'm just making it 0.93. So D value is 0.93. I need not, you can speak much on this. You can see the formula, you can say, from the notes, and the D value is 0.933. So that's the answer, and this is how you can say we are doing this part now. Okay, so this is how we are doing this part. So this is what we are getting for the answer. So we are getting the answer of D value is 0.93. And we know that if D value is 0.2, the effect size is small. If it is 0.5 or near to it, it is medium or average. And if it is 0.8 or it is, you can say, large. In our case, the answer is D value is 0.93. So effect size is large. And coming lastly to the analysis part, which we have to do, I'm repeating the things. Now, when we are going for the analysis part, what we can basically do is we can write the analysis. You have the notes with you. Those notes can be used to understand that how to write the, you can say, standard, you can say, answer, but I'm just speaking the answer. Patients undergoing minimal invasive surgery, within brackets, M is equal to 4.73, comma SD is equal to 1.67, suffer less pain, suffer significantly less pain as compared to patients undergoing traditional surgery, within brackets M is equal to 6.87, comma SD is equal to 1.6 bracket close, comma small t within brackets 28 bracket close is equal to 3.578, comma p is less than 0.001, sorry, p is less than 0.5, comma d is equal to 0.98. So that is how the answer is to be mentioned or written for you. You can look at the notes and see how the answer is being mentioned. So let me again, you can say, go through this particular analysis part with you and see to it that, okay, fine, how are we conducting these analysis? Now, the data is with us. I'll analyze. I'll go for compare means. I'll go for independent sample t-test. I'll click on independent sample t-test. I've got, you can see, the type of surgery performed. So that is my independent variable. It is also grouping variable here. So I'm grouping it as 1 and as 2. Done. I'm saying continue. Pain level, I'm saying pain level is test variable. I'm putting it in the test variable box, which is dependent one. Simply click on OK and I'm getting the answer. So this is the answer I've got. So the answer is before you. Minimal invasive surgery, 15 patients got through this particular, you can say, surgery. The mean level was 4.73 something, and standard deviation was 1.66. Whereas for traditional surgery, the n value is 15 and mean value is 6.87 something, and standard deviation is 1.59 something. So that's done for us. Now coming to all these questions, question A we have discussed, B we have discussed, C part we have discussed, but just discuss it again. The C was talking on the, you can say, is there a difference, you can say, in the population variance? Well, fine. For that, we have to look at the Levin's test. And if you look at the Levin's test here, the value comes to, you can say, the significance value comes to, you can say, 0.943, which is quite higher than 0.05. So had the value of, you can say, the significance or Levin's significance 0.05 or less than that, we would have accepted, you can say, that the population variance difference is there. But since the population variance difference is sorry, we are not saying that population level difference is quite high or is significantly different, because this value of significance is more than 0.05 with f value of 0.005. So this is the answer you can mention for C part, that the degree of you can say difference as far as, you can say, population variances of the two sample is concerned is not much or not significantly different at f value of 0.05, 0.005 and significance of 0.943. So that's there. Coming to, you can say, D part now. In D part, we are talking of, you can say, whether we are accepting the null hypothesis or alternate hypothesis. We'll simply say we accept the alternate hypothesis since the t value is 3.578 with a significance of 0.001. And why I'm saying t is equal to 0 minus, why I'm saying t is equal to 3.578. Remember, you can say we'll never write minus in case of t. It's always it's a neutral thing. We just write 3 or 3.578, nothing like positive plus or minus, because if you look at the t value, you can say t value comes negative here because minimal invasive surgery mean is 4.73, whereas for traditional surgery the mean is 6.86. And it was up to us whether we gave, you can say, the code, the value of, you can say, 1 to minimal invasive surgery in the variable view where we were just making the variables. Had we made MIS or minimal invasive surgery as value 2, and for traditional surgery we had given the value 1, things would have been different and the answer would have been 3.578 instead of minus 3.578. So that being the reason, so we'll avoid this using this term negative here. So that's there. And degree of freedom is 28. We know it because n minus k is the value of degree of freedom. So n is equal to 30, k is equal to 2. We have got two columns. So k is equal to 2. One is for sample 1 and second is for sample 2. So n minus k is 30 minus 2 is 28, and significance comes to, you can say, 0.001, which is highly significant at a confidence interval of 99.9%. So that you can guess now how big the difference is. And now coming to, you can say, the E part, where we will talk about the effect size. Effect size, you can look at the notes and confirm the formula. Small t is equal to t into under root. In the numerator we have got n1 plus n2. In denominator we have got n1 into n2. So calculating all these values, you can put the value of t as 3.578 multiplied by under root n1 plus n2, which is 15 plus 15 is equal to 30. And then in denominator we have got n1 into n2, which is 15 to 15 is 225. So answer that is coming for me by all calculations which I have done is roughly, you can say, d is equal to 0.93. So that is the answer of d. So you can calculate it and see to it that what's the value of d that's coming. One thing more, if you look at the notes, you will find for, you can say, effect size, if d small d is equal to 0.2, it is small. If it is, you can say, d is equal to 0.5 or near to it, it is average or medium. And if it is, you can say, 0.8, it is large. In our case, you can say the value is 0.93, therefore the effect size is large. And lastly, coming to the narration or how we are interpreting the answer, we'll write this way. That is F part of the question I'm answering. Minimal invasive surgery, within brackets, M is equal to 4.373, comma, SD is equal to 1.67, bracket close, has significantly lower pain level as compared to traditional surgery, within brackets, M is equal to 6.87, comma, SD is equal to 1.6, bracket close, comma, small t, bracket open, 28, bracket close, equal to 3.578, comma, p, small p, less than 0.05, comma, d is equal to 0.98. So that was the answer for this question. I suppose you will go through this video again and again to actually, you can say, just understand how the answers are coming up. So thank you.